1.7 is going to be about classifying numbers. So just this fill in the blank here at the top is the first word we need to know, or the first type of number, are rational numbers. So rational numbers are those that can be written in this form here. So you can abbreviate this in your notes. You don't need to write all these sentences out. But what you do need to put in your notes is that they can be written in the form A over B. And then this is key, that they would be terminating or repeating decimals. So terminating meaning the decimal would end like 6.675, 2.25, 3.125. Those would be terminating decimals. Now, not just that on the calculator it stops, because on everybody's calculator your decimal has to stop at some point, but that it ends earlier than that. And then also a rational number would be a repeating decimal. So a pattern. You're looking for a pattern, like 2.666666 and so on. 4.12121212. If there's a pattern or if it repeats, then that is considered a rational number. If it's neither of those, so basically you plug it in your calculator and you get out a decimal that's just no rhyme or reason to it. I call those kind of yucky numbers. Those are irrational numbers. Irrational numbers. And you're going to need to get out your calculators for this so that you can see how this is going to work. So rational numbers fall under real numbers. And so rational numbers are those decimals that are going to repeat, hence that 0.1 with the repeating symbol above it. And then A over B would represent like the fraction where the decimal is going to end. Also, rational numbers are considered integers. So integers are your numbers that are positive and negative on a number line, no fractions, no decimals. Whole numbers are those numbers that you learn to count with, including 0. So it's just in the positives, again, no fractions, no decimals. And then natural or counting numbers are exactly what they sound like. Counting numbers are the numbers you learned when you learned to count, which you started at 1. You didn't start at 0. So all of these, so your natural numbers, your whole numbers, and your integers, all fall under that rational umbrella because those are rational numbers. And the reason they are rational numbers is because an integer, like -3, is a decimal like 0.0. Well, that's a terminating decimal, so that would be an example of a rational number. Whole number, like 6.0, right? That's a terminating decimal, so that's an example of a rational number. And then same thing, obviously, down here with your counting numbers. Anything that doesn't fall under that category, so a nice number that's positives and negatives, no fractions or decimals, or a decimal that's a pattern, or one that ends, if it doesn't fall under that, then we have irrational numbers. And so pi is an example of an irrational number because it goes on and on forever with no pattern. And then square root of 2 is the same thing. Okay, so what you're going to be asked to do is to look at a number and state if it's rational or irrational. And then if it is rational, we want to state any other number sets to which it would belong. Because what we just talked about, remember, if a number is rational, it could also be one of the following, or maybe all three of the following. And so we want to list all the sets to which it belongs. Okay, so the first one, the number 5. That's a nice clean number. So this is a rational number. And I'm just going to put an R. And then we're going to kind of go in order. So if you think back to this chart, or if you turn back to this chart, is the number 5 also an integer? Would the number 5 sit on a number line? It would. And so we're going to say it's an integer. And then is it a whole number? So remember, whole numbers are your counting numbers, including 0. It is. And is it a natural number? Once again, is it a counting number? The answer is yes. So the number 5 is rational, an integer, a whole number, and a natural number. Okay, the number 0. Again, nice number. It's a number that ends. So we know that 0 is a rational number. The question is 0 the next on the list? Is it an integer? Yes, 0 sits on the number line. Is it a whole number? Yes. 0 is included. That's the only difference between whole numbers and natural numbers. Is it a natural number? No, because natural numbers, remember, are your counting numbers. When you learn to count, you don't start at 0. Negative 29, again, it's a number that ends, so we know that that's a rational number. Is it an integer? Yes, because it sits on a number line. Is it a whole number? And the answer is no, it is not a whole number because it's a negative number and whole numbers are only positive. So if it's not a whole number, we don't even need to go into the next box because if it's not whole, it can't possibly be a natural. Okay, 36 over 6, that can be simplified. So if you did that, that's the number 6. And the number 6 is a nice, clean number. So again, that's a rational number. Is it an integer? Does it sit on a number line? Yes. Is it a whole number? So is it positive? Yes. Is it a natural number? Is it one of the numbers that you learn to count? Yes. So it would be all 4. Okay? Next step, we have the square root of 82 over 20. And so you're going to want to, on your calculator, plug this in. And what you're going to see that you get out is this. When I plug in square root of 82 over 20, I get 2.02484567 and that's as far as it goes on my calculator. And so if you're looking at that number, that decimal, it doesn't end. I mean, it does here because a number has to end on a calculator at some point. And there's no pattern. And so this is a nasty number. We call that irrational. Okay? Next, we're going to plug in on our calculator. Plug in the negative symbol and then your square root button and then 22. And when you plug that in, the decimal that you get out is negative 4.69041576. Again, that doesn't end. It has no pattern to it. That's an irrational number. And I guess we should be up here maybe writing INT for integer, so we're not confusing that with the irrational. Okay. And you guys really need to be trying this on a calculator because you need to know how to do square roots and how to do fractions on your calculator. So let me just touch base with you really quickly. If you're looking at your calculator, you're going to have a button on your calculator, and the ones in my room have an x squared button. And then above it in blue, you will see this button, okay? That is not the same as this one. So make sure you're finding the correct one, which is this, okay? So that square root button is in blue. So to activate that blue, I have to hit on my calculator in the top left corner the second button. And it is in blue as well, so that helps me to know to activate the blue, I need to hit the blue button. So you're going to hit second, hit this button first, and then hit this button. And that's going to pop up on your screen as square root and then a parenthesis. And then you're going to plug in whatever is underneath your square root in the problem. So on the last one, I plugged in 82. And then I plugged in, I did it as a fraction. I plugged in my ABC button. That's what a fraction is. And then 20, and then parentheses. And then I hit enter or equals. Okay, so just make sure you know how to plug that in on your calculator. So this one, number 7, we're going to plug in negative 5 divided by 12 on our calculator. So remember, a fraction bar means division. And so when I plug that in, I am getting out negative 0.4166666667. So at the very end, it's going to round it up to 7. But notice this is a pattern. So that means this number is a rational number because it's a decimal with a pattern to it. It cannot fit into any of the others because an integer isn't a fraction or a decimal. So whenever you have a decimal, it can only be either rational or irrational. Okay, number 8. So we're going to plug this in on our calculator. So I'm going to hit second, then that square root button, and then I'm going to plug in 10.24, and I'm going to hit equals, and this is the number 3.2. So that's a clean decimal, one that ends. So this would be a rational number. It cannot Can't even go to the next category because it's a decimal, so we just stop right there. Okay, next we have negative 54 divided by 9, so that's the number negative 6. So nice clean number means it's rational. And then the question is, since it's not a decimal, we can check, is it an integer? Does it sit on a number line? Yes, it's an integer. And is it a whole number? No, because it's in the negative, so we can stop there, because if it's not whole, it can't possibly be a natural number. Okay, next up, we're going to plug this in on our calculator. So we're plugging in the square root of 5.5696, and we're going to get out 2.36. And that's a decimal that ends, so that would be an example of a rational number. Again, it's a decimal, so since it's a decimal, it does not fall into the category of integers, because integers cannot be decimals or fractions. Okay, now we're going to plug in negative, and make sure you plug in your negative sign first. Do not plug it in under your square root. So you're going to plug in negative, and then the square root of 9.16. And this gives us negative 3.02654919. So that's a decimal that just keeps going. No pattern to it, so that's an example of an irrational number. And then lastly, we know that the number pi goes on and on and on forever, that decimal goes on and on, which means that would be an example of an irrational number as well. And that concludes your notes for 1.7.